on our last lesson for 16-5, which is still working with lines of symmetry, but now what we're doing instead was we're going to try to be drawing them. Now, since you're on the computer, it's not going to really match your drawings, so we're just going to do some multiple choice with these ones. Now, our first one says, Chandler tried to complete Sarah's design from the previous page. Describe the error that Chandler made. Now, remember, when we're working on this, we're looking at that line of symmetry, and it's a fold. So remember, when we fold it, the top shape should be the same as the bottom shape. So notice, when I fold it, that green part isn't going to match the blue part. So the mistake Chandler did was Chandler copied the design on the opposite side of the line of symmetry instead, oops, I put inside, so it should have been instead. Instead of using the line of symmetry as a fold. So remember, that key part is our line of symmetry is a fold line. So that's why we capitalize fold. To complete her design. So the key part, again, that line of symmetry is always a fold. So it should completely overlap, it should completely match, it should completely cover. Now, number 2, how can folding a piece of paper help to determine if a line in a figure is a line of symmetry? Well, remember that fold is going to be like our matching pieces. So if the two parts match when the paper is folded, it's a line of symmetry. So again, remember, when we fold that piece of paper, they should match. Now for these ones, it says draw a line of symmetry and complete the design. So remember, when we fold it, it should be the same on the left as it is on the right. So now notice we're folding it. And so I went 2 out, so I need to go 2 out. We went 2 down, so I need to go 2 down. We went 1 in, then 1 up, then 1 in. So notice how my shapes match. Now our next one, there's my line of symmetry, but actually I'm going to erase it, and I want it to be a dotted line. So that dotted line lets me know that, hey, it is a line of symmetry that I'm matching. So I draw 2 out, draw 2 down, 1 over, and then diagonal to connect them. Here again, number 5, they did the line of symmetry for us this time. So now what do we need to do? Well, we need to draw the matching part. So I'm going to start at the end point, so I can pick either side. So I'll start on the left. And notice I go 1 out, so I'm going to go 1 out. Then I go diagonal 1, so I go diagonal 1. Then I go over 2, so I go over 2. Then I go diagonal in, so I go diagonal in. And then I go in, and so I go in. Now notice my shapes match. That top part's the same as the bottom if I were to fold it. Number 6, what do we have here? Well, I think this won't be easy because it looks like a backwards E, which means that it should be a forward E when we make it. So I'm going to go out 2, then I go down 1, go in 1, then I go down 1, out 1, down 1, in 1, down 1, out 1, down 1, and then I go in 2, and it's 2 that last time because remember that other shape, I went in 2 as well. Now this one is a little bit different because I have some different kind of diagonals going in. So I'm going to start my endpoint, and notice I'm going out diagonally 1, so I'm going to go out diagonally 1. Then I went out 1, so I go out 1, and then I go diagonal in 1, and this is our tricky part. Notice how I go diagonal, but it's like 2 jumps. So I need to do the same thing. I go diagonal, but it's 2 dots over. All right, this one, what do we have here? Well, we have a diagonal. And notice it's a diagonal, that goes out, but it's like 2 dots away. So it's not just 1 dot, it's 2 dots. So I'm going to go diagonal out, 2 dots. Then I go diagonal in, 1 dot. I go down 2 dots. I go out 1 dot. Then I go diagonal in, 2 dots. So remember, this diagonal in is going 2 spaces across. Now, this one's going to be tricky because you'll notice our line of symmetry is a diagonal. So we're actually going to do this in some different parts, different pieces. So I go diagonal out 1, then I go down 1 diagonally. So what does that look like? Well, not straight down, because then you notice how my shapes don't match. They need to be in a straight line. So it's diagonal down. So that will look like this. And notice now they're in a straight line if you were to like tilt your head. And now what do we do? Well, we go diagonal, 2 spots, 2 dots. So I'm going to go diagonal 2 spots. But notice it doesn't quite look diagonal when I do it. So that's why you may have to tilt your head to try and get it. Because if I go straight down diagonal, it's going to look like that. So what will it look like here? Well, I'm not sure. So I'm going to do my 2 dots straight from the other point. And now look, when I did it that way, when I start at the other end, it's much more apparent where those last 2 connections go. Now, for number 10. So what do I have here? Well, I'm going to do the same thing I did that last one. I'm going to do part of it from the top, part of it from the bottom when I get stuck or confused. So notice here is going diagonal down. So I'm going to go diagonal down. Still looks like it matches. Then it looks like it goes diagonal, but I'm not quite sure which way. So I'm going to try it from the other end now and see if that makes a little more sense. Let's try diagonal out this way. And then I notice it looks like it's making like a W shape. So I'm going to go down diagonal, which matches the top side. And then I should go up 2 to connect them. And hey, look, it looks like my shape matches. So now let's go to the next part. So now let's head to the next page. So let me switch on over. And it's been a while, so sorry, kind of forgot how to do it. Oh, that's right. I need to exit out of my annotation tools and then swipe. There we go. So now we're ready to begin. So number 11 says, draw a figure that has no lines of symmetry. So that's pretty easy. It's not going to be a rectangle because we've done those many times. It's not going to be a circle. So we need to draw some shape where when we fold it, it's not going to match. So it needs to have some kind of piece that's like different than the other side. So would it be this rectangle? Could it be the circle? Could it be this guy right here? Or could it be this shape down here? 1, 2, 3, or 4. Which one has no lines of symmetry? Well, if you said number 4, you were right. If I were to fold that, the left side wouldn't match the right side. For number 1, a rectangle, we've done them many times. We see it has many. That circle has many. Number 3, we could split it diagonally, and that top part will match the bottom part. Number 4, there's no place we could draw that it would match. So off to number 12. Vanessa drew a figure that has an infinite number of lines of symmetry. What figure could Vanessa have drawn? Well, that means I could keep splitting it in different spots and it will always match. So actually the figure is going to be a circle. And why is that? Well, I could draw one right down the middle. I could draw one horizontally. I could draw it diagonally. I could draw another one diagonally. But I can keep going. I can keep splitting it up like that piece of pizza into many smaller slices. So a circle actually has an infinite number of lines of symmetry. Now for number 13. It says, dogs can smell odors that humans cannot. Dogs can be trained to alert their owners when they smell odors associated with illness. If a dog trains 2 hours every day for 1 year, how many hours has the dog trained? What do the total number of hours equal in days? And about how many weeks? Now, one of the things I didn't like about this was the second part where it says, what do the total number of trained hours equal in days? That really should say about. So let's highlight our important information. He trains 2 hours every day for 1 year. If I look over on the side, it says that there's 365 days in a year. So that's 2 hours every 365 days. So what does that mean? Well, to me, it kind of sounds like we're going to be doing a multiplication problem. We have 365 days, or 365 groups, and 2 goes in each of those groups. So that's 365 times 2. So what is that? Well, 2 times 5 is 10, regroup the 1. 2 times 6 is 12, plus 1 is 13, regroup the 1. 2 times 3 is 6, plus 1 is 7. So what's our answer? How many hours has the dog trained? Well, he's trained 730. Now, this next part, it really should say about. It doesn't, but it should. And the reason why is we now have these hours, this group, and we need to break it up into groups of 24, because there's 24 hours in a day. But we really don't know in 4th grade how to do 730 divided by 24 by a 2-digit divisor. We know how to do it by tens and 1 digits, but not that 2 digits. So it really should say about. So what is 24 close to? Well, I know, using the word about, that doesn't have to be exactly 24. And I know 24 is really close to 25. 25 is an easy number to use. So now I can do 25 goes into about 730. Well, how many times? Well, if I think about it, remember, 4 groups of 25 equals 100. And how many hundreds do I have? Well, I have 700. So I can just count by hundreds and 4s until I get to 700. Is there another easier way though? Because I could do that, but there is a faster way. I could think 7 times 4 is 28, because remember I'm making groups of 4. And so now what do I have? Well, it's about 28 weeks. So now, I'm sorry, 28 days. So now our last part refers to the weeks. So about how many weeks is that? Well, looking at my chart, it says there's 7 days in a week. I have, or 28 days. So what is that? I have 28, and I need to break it down into groups of 7. So that's a division problem. So you have 28 divided by 7 equals 4 weeks. So there we go, all 3 parts of that. Number 14. Claire trained for a long-distance marathon. She ran a total of 225 miles in 3 months. The first month she ran 50 miles. She ran 25 more miles each month. How many miles did she run in her 3rd month of training? Well, let's look at this. It's really going to help me if we do a bar diagram or a tape diagram. So here's my total. We've run it in 3 months, so I'm going to label it as 1, 2, 3 months. And altogether, it equals 225. Now, looking in my text, it says the first month she ran 50, and then it says she ran 25 more miles for the next month. So what is that? Well, we have 50 plus 25, so she ran 25 more, which is 75. So now, what do? Well, we have 2 ways we can do it. We could do 50 plus 75, gives us 125, and then we can see how much we have left to get to that 225. So what would that be? Well, 75 plus 25 is 100, which also matches that 125 plus what equals? So notice, we're adding 25 to each month. So how many miles did she run in her 3rd month of training? Well, she ran 100 miles. So now let's head off to number 15. Can you draw a line that divides a figure in half, but is not a line of symmetry? Use the figures below to explain. So let's look. Well, if I look at that first one, it's folded in half, but it's not a line of symmetry. That top part isn't going to overlay, isn't going to match that other portion on the bottom. So can we cut it in half, but not be a line of symmetry? The answer is yes. The diagonal line divides the rectangle in half, but the diagonal line is not a line of symmetry. So now let's head to just the last part. Which of the following figures is symmetric about the dashed lines? So which one has a line of symmetry using that dashed line? A, B, C, or D? Well, if you pick B, You are correct, because that top part is going to match the bottom part when we fold it. Good job, guys.